Welcome to new edition of Quest Where Do Physics Students. In this video, we are going to do the problems which depends upon the nodal analysis, or simply we can say solving the complex circuits by using the Kirchhoff laws. Mainly here we use the Kirchhoff junction law or current law to solve the circuit. Let's see the circuit, students. Here is a circuit which is given. In this, we have the three cells. Okay, they have different potentials. We have 10, 30 and 14. And also we have three resistors here, 1 ohm, 2 ohm and 2 ohm. Often if you see these circuits, we confuse it over from where we have to start. They are simple logic, students. First we have to decide where is the node is or where is the junction is. If you watch it keenly, you will observe in this entire circuit we have only one junction. Here is the junction. As you learn that a junction is a point where more than two circuit elements will meet. If you watch this carefully, you will find this circuit element which has the resistance of 1 ohm, and here it is a 2 ohm and also 2 ohm are meeting at the junction. We are taking that as the junction point. You can't get any junction here except here. Here it is one more junction. Here to do the problem very easily, we are considering this one, the positive terminal, and it's a negative terminal. Negative terminal of the cell has a potential of 0 volt. I'm considering this cell, which is sending the current. And here also we will get the same. Potential is 0 volt, and here also it is 0. Okay, students, since there is no resistor here along this path, that's why the potential is same. 0 volt, 0 volt and 0 volt. Similarly, if you go to this point, okay, we'll get the potential 10 volt. Okay, students, now see, we are reaching this junction. See the polarity of the circuit. There's a positive terminal. Obviously, it gives the current. Okay, here it is the positive terminal. Is the direction of the current. There is a positive terminal. It is the direction of the current. Let's take the polarity of the cell. It is the negative terminal. That's why I am taking potential as minus 14 volt there. Let's see. It's a 30 volt battery. That means we have the potential which is equal to 30 volt here. And the current is the direction of the current. Okay, students. Here I am considering a point where the potential is X. To solve this circuit, we have to know the potential at this point. By taking it as the reference and using the Kirchhoff law, we can find out the potential here. If you know the potential at this point, obviously you know that here the potential is 10 volt, here it is unknown, here it is the unknown, here known, here the known, and it is the unknown. Okay, by choosing the Kirchhoff junction law, we can solve this circuit. Okay, students, let's adopt the Kirchhoff junction law at a point where the potential is X. Know that according to KJR, okay, sigma I is equal to 0. And I have learned that at a junction, the sum of the incoming currents are equal to sum of the outgoing currents. Let's say here the current is I1, is I2, and is the I3. And also we learned about the Ohm's law. According to Ohm's law, V is equal to IR and I is equal to V by R. Okay, students. Here I can be had. I is equal to V by R. Here I am taking the potential as X here and potential here and resistor is R. I am adapting Ohm's law here. I am writing the relation as here It is x and it's 10. X minus 10. Okay. And resistance is 1 by 1. I'm using this one. Here, the potential difference is I2. And second, and I'm taking this. Okay. Plus x minus 30 series students. And resistance is 2. And here, x plus x minus. Okay, students. Minus of minus 14 by 2 is equal to 0. Okay, students. Now we have to solve the circuit. What you get? X minus 10 plus x by 2 minus 30 by 2 plus x plus 14 by 2 is equal to 0. Or you can write it is x minus 10 plus x by 2 minus 15 plus x by 2 plus 14 by 2 is equal to 0. In other words, x minus 10, x by 2 plus x by 2 plus x minus 15 here plus 7 is equal to 0. Or it can be written as x plus x. 2x minus 25 plus 7 is equal to 0. It gives us 2x minus 18 is equal to 0. Or x is equal to 18 by 2, it is 9. Okay, students. Here maybe in examination we will ask you, what is the potential at x? Okay, these problems are very useful in case of the Neet and as well as the Eamcet exam students. That's why we are taking the simple, complex but simple circuits. We had the potential at point x is equal to 9 volt. Maybe in examination, if you give the circuit and ask you find the potential at this point, you have to adapt the same wherever you want the potential. Okay, students. The first task is over. Then after, we have to find out the current through each branch. I1, say it is I1, and it is I2, and here I3. If you know the current, then we can find out the total current in the circuit also. Let's go with the first. First one, it is what? I is equal to V by R. Okay, students, here x minus, I'm using the same, x minus 10 by R is equal to 1. Okay, the current I1 is the potential difference by resistance. Already we got x as 9. 9 minus 10 by 1. Okay, students, it is 1 amp. Here, I didn't take the negative sign. It indicating that, what is that? The direction what we took is wrong. It's the beauty of the Kirchhoff laws. It will tell us whether the direction is right or wrong. Okay, students, 10 minus 9 by 1 minus 1 amp. Current never be negative. That's why you can take it as the 1 ampere. Okay, students. Then after we are choosing the second one. Okay, x minus I2. The I1, I2 is equal x minus 30 by 2. X is equal to, already we got 9 minus 30 by 2. It is 21 by 2 minus. It is minus 10.5 ampere, and we have to take it as 10.5 ampere. Okay, students. And if you go with the third, x plus 14 by 2 is equal to I3. And on putting the values, x is equal to 9 plus 14 by 2. It is 23 by 2. Okay, 11.5 ampere. In this way, we can get the current, students. to one more problem, students, which depends upon the Kirchhoff junction law. Actually, we call it as the nodal analysis, students. Here we got a node here, is A, and here the point is given has a potential of 10 volt, and a cell is kept here. It has a potential of 20. Here the minus 30 volt is there, and maybe this resistance is equal to 1 ohm. We are taking here it is a 15 volt cell on the battery, 2 ohm, and here also 20 volt. It is a minus 50, it's 5. He is asking us find the potential at A. Let's say the potential at A is equal to x squared 5. We have to use the Kirchhoff junction law here. As you learn that, according to the Kirchhoff junction law, sigma I is equal to 0. We are using this, and also we are using the what that Ohm's law. According to that, sigma V is equal to 0 or V is equal to IR. Yes, these two laws we have used. Here say it is the potential X as a positive, and here also positive. Okay, students. Okay, students, here we are applying the Kirchhoff junction law to this the part of the circuit. Here the potential what we have to find is X. I'm taking it as X minus 20, plus to minus we are doing minus 20, and here resistor is 1 and 10. It is minus 10 by the resistance is 1. Okay, similarly, plus we are moving from here to here, plus to minus X minus 15 minus 20, okay, by resistance by 2. Okay, student, then come to here. X minus 30 by 1 plus X minus 5, okay, minus of minus 50, minus of minus plus 50, plus 15 minus 5. What is X plus 45 by 2 is equal to 0. See here, it is X minus 5 minus of minus 50. X minus 5 plus 50. That's why I wrote it is X plus 45. Okay, students, further it can be written as X minus 30 plus X minus 35 by 2 plus X plus 30 by 1 plus X plus 45 by 2 is equal to 0. Then what you get? X minus 30 plus X plus 30 plus X minus 35 by 2 plus X plus 45 by 2 is equal to 0. Here 30 get cancelled. It is 2x. We are taking 1 by 2 as a common. 1 by 2 of X minus 35 plus X plus 45 is equal to 0. Then it can be written as 2x plus 1 by 2 into X plus X, 2x plus 10 is equal to 0. It's 2x plus 2x by 2 0. In other words, equals 2x plus x plus 5 is equal to 0. 3x plus 5 is equal to 0. 3x is equal to minus 5, or x is equal to minus 5 by 3. 4. It is the desired answer, students. By using the nodal analysis, you can find out the potential at anywhere. In the same way, you can calculate the current through this branch, this, and this by using the same. Like we did before. Every time you get I and substitute the value of x as minus 3 in this equation, we get the current in the branch, this one, which is associated with this. Similarly, here we can get the current through the next branch, third branch, and fourth branch. It is the easiest way to find out the potentials and as well as the currents, okay, by using the nodal analysis, students. I hope you understood the problems well. If you like the problems, please subscribe my channel. Okay, students.